How to represent a circular singly linked list in Java.
So friends, before we start, in case if you're new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update.
So friends, what is a circular singly linked list? So if you see, this is how we represent a singly linked list and this is how we represent a circular singly linked list. So the structure wise, circular singly linked list is very much similar to singly linked list. And here you can see in singly linked list we have these nodes which form a chain, and we keep a head node which points to the first node and the last node next point to the null. So the only difference between singly linked list and circular singly linked list is that in circular singly linked list the last node points to the first node and not null. So here if you see, in singly linked list the last node next is pointing to null, but in circular singly linked list the last node next is pointing to the first node again and not null. So therefore this property makes circular singly linked list circular in nature, where if you see 1 points to 8, 8 points to 10, 10 points to 16 and 16 again points to 1. So therefore it's a circular in nature. And one more difference is, like in singly linked list we keep the track of the head node which is pointing to the first node, but in circular singly linked list we keep the track of the last node. So in circular singly linked list we keep the track of the last node because it helps us in insertion and deletion of the nodes in constant time. So here if you see, as head points to the first node, and suppose if we want to insert a node in a singly linked list at the end, so we need to traverse each and every node in the singly linked list to reach the last node and then add the particular node. But here in circular singly linked list we are keeping the track of the last node, and if suppose we want to insert a node at the end, so we can directly use this last pointer and add the node at the end. And suppose if we want to insert a node at the beginning, then we know that a circular singly linked list is circular in nature. Therefore, when we do last dot next, we reach to the first node. So we can directly add node at the beginning in constant time. So friend, this is how we represent a circular singly linked list, where we keep the track of the last node and last node next points to the first node. So friends, let's see a demonstration of circular singly linked list. Below you can see that circular singly linked list has 3 nodes having data as 1, 8 and 10, and the node having data as 10 has been referred by the last node, and you can see it's a last node in a circular singly linked list where its next is pointing to the first node. So let's see a small demo how we can create this circular singly linked list. So suppose we initialize a circular singly linked list. So we know that the list is empty, so therefore the last will point to null. So when the list is empty, the last node is pointing to null. Now let's suppose we are inserting this node having the data as 1. So it's a simple node having data as 1 and next is pointing to null. So if we want to insert this node into the circular singly linked list, and as the list is empty, we'll simply assign the value of temp into last, so that last points to this node. So it would look something like this. So now the last node is pointing to the node having data as 1, and we also know that circular singly linked list has property that last next points to the first node of a circular singly linked list. But here if you see, there is only one node. So basically this node is the last node of a circular singly linked list and also the first node. So last next should point to this node only. So it would look something like this. So when we insert a node into an empty circular singly linked list, last points to that particular node and its next points to the node itself. Now let's suppose we want to add one more node having data as 8. So here you can see the temp is pointing to this node having data as 8 and its next is pointing to null. So in order to insert this node into the circular singly linked list having data as 1 and last is pointing to 1. So what we do is, when we insert this node with a value 8, we know that its next should point to the first node. So therefore what we do is we simply break this link and we point it to the first node. So it would look something like this, as temp next is pointing to the first node. And here if you see, the first node is pointing to the second node. Therefore we need to break this link and we need to point it to the second node. So it would look something like this. So now you can see that node 1 is pointing to node 8 and node 8 is again pointing to node 1. So they are circular in nature. And one last step we need to do is, as we have inserted is node 8 and we know that this is the last node, therefore we'll simply assign the value of temp to last. So it would look something like this. So after the insertion of node having data as 8, the circular singly linked list looks like this, where node having data as 8 is pointed by the last node and its next points to the first node. Therefore it maintains a circular property. And let's suppose we want to add one more node having data as 10. So here if you see, the node next is pointing to this first node. So in the first step what we'll do, we'll simply remove this link and we'll point it to the first node. So it would look something like this. So now temp next is pointing to the first node. And here you can see that second node is pointing to the third node. So but here second node is pointing to the first node. So we need to simply break this link and we need to point it to the third node. So it would look something like this. And one last step we need to do is, when we have inserted this node having data as 10, we know this is the last node, therefore we simply need to refer the value of temp to the last. So it would look something like this. So friends, here if you see, we inserted 3 nodes and we knew that node 1 is the first node and node having data as 10 is the last node, and here the last node is pointing back to this first node. So therefore we saw how circular singly linked list is created and how they maintain a circular property. How to implement a circular singly linked list in Java. So friends, in my previous tutorial we discussed how we can represent a circular singly linked list. We discussed that it's very similar to singly linked list, with a slight difference that in singly linked list the last node points to null, but in circular singly linked list the last node points to the first node, which makes this data structure circular in nature. We also discussed that we use head node to keep the track of singly linked list, but in circular singly linked list we usually keep the track of the last node. So friends, in my previous tutorial we discussed about the circular singly linked list representation. So in this tutorial we will discuss how we can implement a circular singly linked list in Java. So let's go to Eclipse and see the working code. So friends, in order to implement a circular singly linked list, I have created one class by name circular singly linked list. So in this class we will write the code for circular singly linked list implementation. Now here we will first create few instance variable. So private So here we have created an instance variable of type list node by name last. So this list node will help us in keeping the track of the last node of a circular singly linked list. We will also create one more instance variable. So here we have created an integer variable by name length. So this length variable will hold the size of this circular singly linked list. And inside this circular singly linked list, we'll create a private class of list node. So as this is very similar to singly linked list which we saw in our previous slide, so I will just code what's required in list node. So private list node next. So here list node contains the data part and a reference to the next list node. We'll create one constructor. Now this constructor will take the data part. Moving ahead, we'll create a constructor for this circular singly linked list class. So friends, when we initialize circular singly linked list, we know that last points to null, and as the list is empty, therefore length would be 0. So here we also create one more method, public int length. So when we call this method, it should return us back the size of circular singly linked list. So we simply return length. We'll also create one boolean method by name is empty. Now this method will return us back whether the circular singly linked list is empty or not. So we'll simply return that when length is 0, then return true, and when length is not 0, then simply return false. So let's say in our main method, I create the instance of circular singly linked list. So friends, here we will write one more method which can create the circular singly linked list. So we'll simply create one method as public void create circular linked list. So here we'll first create few nodes. Say first, let's say I give data as 1. I'll copy this. Let's say I give data as 5, 10, 15. And I will change the name as second, third. So friends, we have created these 4 nodes. Now we'll interconnect them. So first should point to second. So we'll do first dot next and assign a value of second to it. And similarly second dot next and assign a value of third to it. And similarly third dot next and assign a value of fourth to it. Now friends, here you see first points to second, second points to third, and third points to fourth. But fourth is pointing to null. Therefore, in order to make this linked list circular, we'll simply do fourth dot next and assign first to it. So therefore now fourth node will point to first node again. So it will make it in circular in nature. And in last, what we'll do, the instance variable which we created last, it should point to the last node. Therefore, we'll assign the value of fourth to last. So friend, this is how we represent a circular singly linked list in Java. And if you want to call this method, we can simply do csll.create. So this will create a circular singly linked list of 4 nodes, where first will point to second, second will point to third, third will point to fourth, and fourth will again point to first. And we can track those changes using the last list node. So friend, this is how we implement a circular singly linked list in Java. How to traverse and print a circular singly linked list in Java. So friends, in my previous tutorial we discussed how we can represent a circular singly linked list, and we also saw how we can implement the circular singly linked list in Java. So in this tutorial we will discuss how we can traverse and print the elements of a circular singly linked list in Java. So here you see below is the algorithm to traverse the circular singly linked list and print the elements data. So here let's see an example when the circular singly linked list is completely empty and last is pointing to null. So friends, we know that when the circular singly linked list is empty, therefore there are no elements and last will point to null. So here when the last points to null, we know that there are no nodes inside this circular singly linked list to traverse. Therefore we are keeping one condition as when the last points to null, then simply return. So here we know that last is pointing to null. So we will simply return from it. So friends, let's see the demonstration of the algorithm with the circular singly linked list having 4 nodes, say 1, 8, 10 and 16, where 16 is the last node and its next is pointing to this first node. Now let's see how we can traverse each element inside this circular singly linked list and print the data with the respective node. So here first we'll check whether last is null or not. So as last is pointing to this fourth node, therefore it's not null. So the condition in if block comes out to be false. So we move ahead. Now friends, as we know that we are keeping the track of this last node, which is the fourth node, and suppose if we want to traverse each and every node and print the data, so we need to start with the first node and then we can print the data accordingly. But as here we are only keeping the track of the last node, so therefore in order to reach this first node, we know that the last node next points to the first node, and we need to traverse circular singly linked list from the first to the last node. So therefore we'll create this first node and we'll assign the value of last dot next to it. So it would look something like this. Moving ahead. So friends, we know that circular singly linked list is basically circular in nature, where first node points to second, second points to third, third points to fourth, and fourth points to the first again. So we need to provide a while loop to traverse each and every node, and we need to take a special care while placing the condition in while loop, because if we place some wrong condition, then we know that as it is circular in nature, therefore this while loop may enter into an infinite loop. So here as we want to traverse each and every node and print the data into the respective node, so we'll traverse till we have reached the last node. So the condition in while loop will put as will iterate till first is not equal to last, because when first is equal to last, we know that we have traversed each and every node. So currently first is pointing to this first node and last is pointing to this fourth node, therefore first is not equal to last. So the condition in while loop comes out to be true. So in the first step we'll simply print the data associated with this first node. Moving ahead. So friends, as we have traversed this node, now we need to just move to its next node. So in order to move this first node to its next, we'll simply assign the value of first dot next to first. So here if you see, first is pointing to this first node and its next is pointing to the second node. Therefore we are simply assigning the value of first dot next to first. So it would look something like this. So it simply traverses first to its next position by this statement. Moving ahead. Now again first is not equal to last, therefore condition in while loop comes out to be true. So we'll simply print the data associated with the first node. Moving ahead. Now as we have traversed the second node, so we'll move to the next node. So in order to move this first to its next, we'll simply assign first dot next value to first. So first dot next points to the third node. So after this statement, it would look something like this. Moving ahead, now again, first is not equal to last. Therefore, the condition in while loop comes out to be true. So in first step, we'll simply print the data associated with this third node. And in the second step, we'll simply traverse first to its next by assigning first.next value to first. So it would look something like this. Moving ahead, so friends, now here you see first and last both are pointing to this fourth node. Therefore, first is equal to last. So the condition in while loop comes out to be false. So therefore, the while loop breaks out. So friends, here you can see that we had this pointer to this last node and we started traversing and printing of the elements from the first node. So here if you see, the circular singly linked list has 4 nodes and we have traversed 3 nodes by printing 1, 8 and 10. And then in the while loop, when we traverse to the last node, we know that condition in while loop came out to be false as first is equal to last. Therefore, we have reached to this node, but we haven't printed the data for this last element. So therefore, in the last step, we'll simply print the data associated with this fourth node. So when we print the data associated with fourth node, we are sure that we have traversed all the nodes and we have print the data associated with the respective nodes. So friends, we saw the demonstration of the algorithm. Now let's move to Eclipse and see the working of the code. So friends, in my previous tutorial, I created one class by name circular singly linked list. And we saw the implementation of circular singly linked list in that tutorial. We basically created few instance variable by name length and last. So this last node was used to keep the track of the last node in circular singly linked list. We also saw how we can create a circular singly linked list and we added these 4 nodes 1, 5, 10 and 15 and we made this linked list circular by assigning this fourth node again to the first. So friends, in this tutorial we will write the code to traverse and print the elements of a circular singly linked list. So we'll create a method as public void. We give the name as display. So this method will simply traverse each and every element in a circular singly linked list and print the data with the respective node. So here first we'll provide a condition as if last equals null. So it means that if circular singly linked list is empty or not. So if circular singly linked list is empty, then we'll simply return and do nothing. Moving ahead, we'll create a list node by name first and we'll assign the value of last dot next to it. So this thing we are doing because we need to traverse the circular singly linked list from first position to the last position and we know that last dot next points to first. So we are simply creating a list node by name first and we are assigning the value of last dot next to it. And then we'll create a while loop. So inside this while loop, we will traverse each and every node of circular singly linked list using this first node. So the condition we provide in while loop is we will traverse this first till it becomes last. And in the while loop, we'll simply first print the data associated with the first node. And in the next step, we'll simply traverse first to its next node by assigning first dot next value to first. So here in this while loop, what we are doing is we are printing the data associated with the first node and then we are simply traversing first to its next node by assigning first dot next value to first. So when we are reaching to the last node, we need to print the data associated with the last node as well. So we'll simply print first dot data. Now in main method, let's see the demonstration of this display method. So here first we'll create the instance of circular singly linked list, and then we'll create the circular singly linked list by calling create circular linked list method. So in this method we are simply creating 4 nodes, where first is pointing to second, second is pointing to third, and third is pointing to fourth. And as fourth is the last node, therefore fourth will point again back to the first node. And in the last step we are simply assigning the value of 4 to last, because we are holding this circular singly linked list through this last instance variable. Now let's say we are calling this display method, and if I run the code, so friends, here you see it prints 1, 5, 10, 15, which are actually the 4 nodes in our circular singly linked list. How to insert node at the beginning of a circular singly linked list in Java. So friends, in my previous tutorial we discussed about circular singly linked list. So here if you see, below is the algorithm to insert a node at the beginning of a circular singly linked list. So here if you see, when the circular singly linked list is empty, the last node points to null because there are no nodes inside the circular singly linked list. And you see the length is 0. So friends, let's see the demonstration of this algorithm. Let's suppose we want to insert a node at the beginning of a circular singly linked list. So in the first step, what we are doing is we are creating a list node by name temp, and we are passing in the data which we actually want to insert. So it looks something like this. So your temp variable is pointing to this list node having data as 1 and whose next is pointing to null. Moving ahead. Now in the second statement, we usually check whether this circular singly linked list is empty or not. So we provide a condition that whether last is equal to null or not. So here if you see, last is pointing to null, therefore the circular singly linked list is empty. So the condition comes out to be true. So in order to insert this temporary node into the circular singly linked list at the beginning, the first step we do is we assign the value of temp to last. So it looks something like this. And after this step, temp and last both point to this particular node. As this circular singly linked list is empty and we want to insert this node at the beginning, so when we insert this particular node, we know that the circular singly linked list has only one node. The last node points to that particular node. So therefore, we have assigned the value of temp to last. Moving ahead. Now after the if else block, what we do is we simply assign the value of temp to last.next. Now why we are doing this step is because here we know that we are basically inserting a node at the beginning of a circular singly linked list. And we also know that circular singly linked list has property that the last node usually refers to the first node. And as we are inserting a node at the beginning, we know that the last next should point to this particular node. And here if you see, when we are inserting a node into an empty circular singly linked list, we know that after an insertion, there is only one node, which is the first and the last node both. And we want to make the last dot next point to first node. So in order to do that, what we are doing is we are assigning last dot next value to the node itself. And here we know that temp is pointing to this particular node. So it looks something like this. So this link is gone, and then it will refer to itself because temp is pointing to this node only. So after this step, last next will point to the node itself. And here if you see, it is also fulfilling the property of circular singly linked list, as last node is pointing to the first node. And since this is the only node in the circular singly linked list, therefore last node and the first node is the node itself. Therefore here it is referring to itself. Moving ahead. So after we insert the node into circular singly linked list, we usually increment the length by 1 because we know that now circular singly linked list has size 1. So now the value stored in the length will be 1. So when the method gets executed, circular singly linked list looks like this. So friends, let's insert one more node into the circular singly linked list having the length as 1. So usually in the first step we create this temporary list node having the data which we want to pass. So let's say we are taking a node having data as 8 and the temporary node is pointing to it and its next is pointing to null. So this node we want to insert at the beginning of this circular singly linked list. Therefore, we need to insert the node just before the node having the data as 1. So let's see the demonstration step by step. So in the first step, we usually check whether the circular singly linked list is empty or not. So we make an if check that whether last is pointing to null or not. So here last is pointing to this node, therefore the circular singly linked list is not empty. So the condition comes out to be false. So therefore the else block will be executed. So in the else block what we do is we assign the value of last.next to temp.next. So here if you see last.next is pointing to the node itself and temp.next is pointing to null. So why we are doing this step is because we want to insert the node at the beginning. So therefore this node should come just before this. So when this node will be inserted, this would be the first node and this would be the last node. And as this would be the first node, its next should point to this node. So in order to do that, we need to break this link and we need to assign this link to last.next. So here if you see last.next is pointing to the last node itself. And we want to insert this node just before this. Therefore, we need to assign the value of last.next to temp.next. So it looks something like this. So now temp.next is pointing to last.next. Moving ahead. And then what we do is we simply assign the value of temp to last.next. So friends, in this step what we are doing is once we insert this node would be the part of circular singly linked list and this would be the first node. And we also know that circular singly linked list has property that last node will always point to the first node. Therefore, last next should point to this node because that is the circular singly linked list property. So in order to do that, we are simply assigning the value of temp to last.next. So it would look something like this. And as we want to insert this node at the beginning of a circular singly linked list, we know that last.next should point to this node because after an insertion, this node will become our first node. We increment the length by 1. So after the method is executed, we know that circular singly linked list has 2 nodes and length is 2. Now friends, let's suppose we want to insert one more node. So in the first step, we'll create the list node by name temp. So here it would look something like this. The temp is pointing to the node having data as 10 and its next is pointing to null. Now this node we want to insert at the beginning. Therefore we know that this node should come just before 8 and once this node is inserted, this node will become our first node. So let's see the demonstration of algorithm. So first we'll check whether list is empty or not. So as last is pointing to the node having data as 1, therefore the list is not empty. So in the else block, we are simply assigning value of last.next to temp next. So friends, as we want to insert this temporary node at the beginning of a circular singly linked list and the first node is having the data as 8. Therefore when we want to insert this temporary node just before that, then we need to make this pointer point to this particular node. And in order to reach this particular node, we know that we are keeping the track of the last node. And when we do last.next, we are reaching to the first node. Therefore, we are simply assigning the value of last.next to temp next. So it would look something like this. Now here temp.next is pointing to the first node of a circular singly linked list. Moving ahead, and the last step we do is, as we want to insert this temporary node, so once this node is inserted, we know that this would become our first node, and we know that circular singly linked list has property that last node next should point to the first node. Therefore here we are simply assigning the value of temp to last.next. So it would look something like this. And the final step, we are incrementing the length by 1. Currently the circular singly linked list has 3 nodes, where first node has data is 10, second node has data is 8, and the last node has data is 1. And last next is pointing to the first node. So after the method gets executed, the circular singly linked list looks like this. So friends, here we inserted 3 nodes having data as 1, 8 and 10 at the beginning of a circular singly linked list. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, we discussed about circular singly linked list and its implementation. We created one class by name circular singly linked list. So in this tutorial, we will write a method which will insert the node at the beginning of a circular singly linked list. So let's say I give the name of method as public void insert first. So here I have created one method by name insert first. So this method will take the data part which is of integer type. So in the first step, we'll create a list node by name temp. And here we pass the data into the constructor. So therefore in this step, we are simply creating a list node of the data which we have passed into the method. Now in the next step, we are providing a if check that last is equal to null or not. So if the circular singly linked list is empty, therefore in the if statement, we are simply assigning the value of temp to last. So last equals temp. Moving ahead, and if the circular singly linked list is not empty, then we are simply assigning value of last.next to temp.next. And after the if else block, we are assigning the value of temp to last.next. So last.next equals temp. And then we are simply incrementing the size of circular linked list by 1. So friend, this is the code for insertion of a node into the beginning of a circular singly linked list. So here we first create the list node, then we check whether the list is empty or not. So if the circular singly linked list is empty, then we simply assign the value of this temporary node to last. And if the circular singly linked list is not empty, then we simply assign the value of last.next to temp.next, which we saw in the slide. And the last step, we usually assign the value of temp to last.next, and then we increment the length by 1. Now in the main method, let's test the working of this insert first method. So in my previous tutorial, in the main method, we created the instance of circular singly linked list. And let's say using that instance, we call insert first. And we provide the data as 10. And finally, we call the display method. So if I run the code, so you see it printed value as 10. Now let's say I call this method again and provide data as 15. And if I run the program, so you see it printed 15 and then 10. So here when the circular singly linked list was empty, we called insert first and passed value as 10. So the node having data as 10 was the only node into the circular singly linked list. And when we inserted 15, So here we are inserting 15 at the beginning of a circular singly linked list. So this circular singly linked list had only node having data as 10. So when we inserted 15, it got inserted just before the node having data as 10. So if you want to insert one more node, say of data 25, so this 25 will be inserted just before the node having data as 15. So if I run the code, so you see it printed 25, 15 and then 10. How to insert node at the end of a circular singly linked list in Java. So friends, let's suppose we are given an empty circular singly linked list. So when the circular singly linked list is empty, we know that the last node points to null. And in order to understand what this last node is, you need to watch my previous tutorials. So in this tutorial, we will be discussing how to insert a node at the end of a circular singly linked list in Java. So let's see the demonstration of this algorithm step by step. So we also know that when the circular singly linked is empty, length is 0. Now in order to insert a node in a circular singly linked list at the end, the first step we do is we basically create a node and we'll pass the data. So here we have created one node having the data as 1 and which is being referred by this temp node and whose next is pointing to null. Now we want to insert this node at the end of a circular singly linked list. So moving ahead. So the first step we check is whether the last is equal to null or not. So if the last is equal to null, then we know that circular singly linked is empty. So therefore the condition in if block comes out to be true. So here the first step we do is we simply assign the value of temp to last. Now as the circular singly linked list is empty, so therefore there are no nodes. And as we want to insert this temporary node at the end of the circular singly linked list, so when we insert this temporary node into the empty list, we know that after its insertion, this would be the only node in the circular singly linked list. Therefore, last should point to this node. So in the first step, we are simply assigning value of temp to last. So it would look something like this. Moving ahead. Now in the second step, we are assigning value of last to last.next. So why we are doing this step is we need to fulfill circular singly linked list property that last next should point to first node. And as we know that this is the only node in the circular singly linked list, therefore the last and the first node is the node itself. So we are assigning value of last to last.next. So it would look something like this. So this link is gone and now this last.next will refer to the node itself. So it would look something like this. And in the last step, we'll simply increment the length by 1 because we have successfully inserted the node at the end of a circular singly linked list. So friends, once this algorithm is executed, we know that initially circular singly linked list was empty and now it contains only one node. So it is referred by last because this is the only node and its next is pointing to the first node, which is the node itself. So now if we call this algorithm again and we want to insert one more node, so let's see the demonstration of the algorithm. Now in the first step, we'll simply create the list node and provide the data which we have passed into the method. So it would look something like this. The temp is pointing to the node having data as 8 and whose next is pointing to null. Now let's say we want to insert this node at the end of a circular singly linked list. So let's see the demonstration step by step. So we check whether last is equal to null or not. So now the last is pointing to one node, therefore it's not equal to null. Therefore the condition in if block comes out to be false. So the else part will be executed. So in the else block, the first step we do is we assign the value of last.next to temp.next. So here why we are doing this step is as we want to insert this temporary node at the end of a circular singly linked list, we know that after its insertion, the node which is referred by temp would be the last node. So if it is a last node, then its next should point to the first node. And how to reach the first node? We know that currently the node which is referred by last, its next is the first node. Therefore, we are simply assigning last.next value to temp.next. So it would look something like this. So this link will be removed and it would refer to the first node. And in order to reach the first node, we know that last next refers to the first node. Therefore, temp next will now refer to the node having data as 1. So it would look something like this. So currently you see we have two nodes where temporary next is pointing to this first node. So moving ahead, and in the second step we are assigning value of temp to last.next. Now here you can see last.next is referring to itself, and we know that when we insert this node, last next should refer to this node because then it will form a chain. So we are simply assigning value of temp to last.next. So it would look something like this. So now this link will be gone and now it should refer to this temp node. So moving ahead, and in the last step we are simply assigning value of temp to last. Now we are doing this step is because we have inserted the node at the end of a circular singly linked list, and we know that we are keeping track of this last pointer. So after this temporary node is inserted into circular singly linked list, we know that this becomes the last node. Therefore we need to assign the value of temp to last, so that last refers to the last node of a circular singly linked list. So it would look something like this. So in the final step we'll simply increment the length by 1. The circular singly linked list has two nodes, and we can also see that the last next is referring to this first node. Now friends, let's suppose we want to insert one more node into this circular singly linked list. So we'll execute this algorithm again and we'll pass the data into the method. So let's see the demonstration of this algorithm step by step. So in the first step we'll simply create a list node and we'll refer it to by temporary variable. So here you can see we have simply created a temporary node having data as 10 and whose next is pointing to null. And now we want to insert this node at the end of the circular singly linked list. So let's see the demonstration of this algorithm step by step. Now the first step will check whether last is equal to null or not. So currently last is pointing to the second node, therefore it's not null. So the condition in if block comes out to be false. So the else part will be executed. So the first step in else part we do is we simply assign the value of last.next to temp.next. So here you can see last.next is pointing to this first node and temp.next is pointing to null. And as we want to insert this node at the end of a circular singly linked list, we know that after its insertion, this temporary node becomes the last node. Therefore, its next should point to the first node. And in order to reach this first node, we know that last next is referring to it. Therefore, we'll simply assign value of last.next to temp.next. So it would look something like this. So now you can see temp next is pointing to this first node. Moving ahead. In the second step, we simply assign value of temp to last.next. So here, in order to insert this node at the end of a circular singly linked list, we know that initially this list contains two nodes, and in order to insert this third node, we need to break temp.next link, which is referring to first node, and we need to assign it to the temp node, because then this third node will be a part of a chain. So in this step we are simply assigning value of temp to last.next. So it would look something like this. So this link is broken and now it will point to this temporary node. Moving ahead. In the final step we know that as we have inserted this node, which is at the last position, we'll simply assign value of temp to last. So it would look something like this. And now in the last step we'll simply increment the length by 1. So friends, here you can see the length of the circular singly linked list is of size 3, as we have 3 nodes with data is 1, 8 and 10, and the last node next is pointing to the first node. So friends, this was the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, I created one class by name circular singly linked list, and we implemented circular singly linked list into the class. So in this tutorial, we will simply write a method which would insert a node at the end of a circular singly linked list. So I'll create one method as public void insert last, and to this method I will pass an integer value which will actually hold the data of the list node. So in the first step, we'll simply create the list node by name temp, and we'll pass the data into the constructor, and then we'll provide an if else block. So in the if, we'll provide a condition as whether list is empty or not. So we'll simply check whether last is equal to null or not, or we can also call isEmpty method, which we have discussed in my previous tutorials. So friends, if the list is empty, then we'll simply assign value of temp to last, and in the second step we'll simply assign value of last to last.next, which we discussed in the slide. And in the else part, so in the first step, what we do is we assign the value of last.next to temp.next. In the second step, we assign the value of temp to last.next. And finally, we assign the value of temp to last. And as we discussed in the slide, once we insert the node at the end of a circular singly linked list, we increment the length by 1. So length plus plus. So friend, this is the code to insert the node at the end of a circular singly linked list. Now let's test this method into the main method. So in the main method, I have created an instance of circular singly linked list. So let's add few nodes at the end of the circular singly linked list. So here we will add the nodes which we saw in the slide. So insert last, and let's say I provide data as 1. And if I print the circular singly linked list by calling display method, you can see when I run the code, it prints 1, because initially circular singly linked list is empty, and when we insert one node at the end of the circular singly linked list, we only get this one node. Now let's insert one more node, and I provide data as 8, and when I run this code, you can see it printed 1 and then 8. So therefore it inserted 8 at the end of the circular singly linked list. Now let's say I insert one more node having data as 10, and if I run this code, you can see it printed 10. So friends, here we inserted 3 nodes at the end of the circular singly linked list. So first we inserted 1, then we inserted 8. So 8 was inserted at the last position, and finally we inserted 10. So you can see the 10 is inserted just after 8, and which is the last node. How to remove first node from a circular singly linked list in Java. So friends, let's suppose we are given a circular singly linked list having 3 nodes, say 1, 8 and 10, whose length is 3. So friends, in our previous tutorial, we discussed that we are keeping the track of the last node of the circular singly linked list through the last instance variable. So friends, below is the algorithm to remove the first node from a circular singly linked list in Java. So let's see the demonstration of this algorithm step by step. So the first thing we do is we check whether the circular singly linked list is empty or not. So if you see, circular singly linked list has 3 nodes and length is 3. therefore it's not empty. So the condition in if block comes out to be false. Moving ahead. Now in order to remove the first node from a circular singly linked list, we know that we are keeping the track of the last node, and in the circular singly linked list, last node next points to the first node. So therefore here we are creating a temp node and we are assigning the value of last dot next to it. So this temp will point to the first node because in the circular singly linked list, last next points to the first node. So it would look something like this. Moving ahead. So here we are providing an if else block, and in the if block we are checking that whether last dot next is equal to last or not. So this condition comes into picture when the circular singly linked list has only one node left. So in this case, last next points to the last because the circular singly linked list has only one element where first and the last node is the node itself. So here you can see last next is pointing to this first node and therefore it's not equal to last. So the condition in if block comes out to be false and the else part will be executed. So in the else part, the first step we do is we assign the value of temp.next to last.next. Now friends, as we want to remove this first node, we need to do two things. First, we need to break this link which is being referred by last.next to the first node. So in order to remove this link, what we are doing, we are simply assigning the value of temp.next to last.next. So friends, here if you see, when we remove this first node from the circular singly linked list, the node having the data as 8 becomes the first node because this node is removed. And we also know that circular singly linked list has property that last next points to the first node. So in this step, we are simply assigning the value of temp next to last.next. Now why we are doing this step is because once the first node is removed, the second node becomes the first node. So therefore last.next should point to the second node. So when this step is executed, it looks something like this. That last.next is removed and we will assign the value of temp.next to last.next. So it would look something like this. So we are breaking the link of last.next to the first node and then we are assigning it to the second node because when the first node is removed, the second node becomes our new first node. Moving ahead. And after the if else block, we simply assign the value of null to temp.next. So friends, as we are removing this first node and returning it from the method, therefore we need to break this link as well. So in order to break this link, we are simply assigning null value to temp.next. So it would look something like this. Moving ahead. And then we are decrementing the length by 1 because we know that we have removed this node from the circular singly linked list. So initially the length was 3. So now it will become 2. Moving ahead. And then we are simply returning this temp node because we have already removed it from the circular singly linked list. So it would look something like this. So friends, as soon as we have removed this link, we know that we are currently left with 2 nodes. And here you can see the node having the data as 8 becomes our new first node. And you can also see last next is pointing to this node. Therefore, if we again call this algorithm and we want to remove the first node of a circular singly linked list, the algorithm goes as follows. So again, first we check whether the circular singly linked is empty or not. So here you can see circular singly linked list has 2 nodes, therefore it's not empty. So the condition in if block comes out to be false. And the first step, we are simply creating the temp node and assigning the value of last dot next to it. So friends, here as we track the last node of the circular singly linked list and we want to remove the first node, therefore in order to reach the first node, what we do, we simply do last dot next. So this value we are assigning to a temp node and it would look something like this. So here you can see last dot next is pointing to this first node and we are assigning that value to temp. So now temp will point to the node having data as 8. Moving ahead. And then in the if block we are checking that whether last dot next is equal to last or not. So currently last dot next is pointing to this first node. Therefore last dot next is not equal to last. So the condition in if block comes out to be false and the else part will be executed. So friends, in the else part, what we are doing, we are simply assigning the value of temp.next to last.next. So in order to remove the node having data as 8, we need to first break this link which is being referred by last.next. And we also know that when we remove this particular node from the circular singly linked list, we are left with only one node. So therefore last.next should point to that particular node. So friends, here we are assigning the value of temp.next to last.next. So we know that we have to remove this link, and when we remove this particular node having data as 8, we know that now 10 will become our first and the last node both. Therefore we are simply assigning the value of temp next, which is the node having data as 10, to last next. So it would look something like this. So here you can see the link is removed, and then we are assigning temp next to last next. So it would look something like this. So friends, here we have removed the link which is referring to this particular node which we want to remove. Moving ahead, and then we are simply assigning the value of null to temp.next, because as we are returning this complete node, we need to break this link. So it would look something like this. So now temp.next, instead of pointing to the node having data as 10, it is now pointing to null. And as we have removed this node from the circular singly linked list, we will decrement the length. So now length is 1 because we have only one node left. And in the final step, we are simply returning the temp. So it would look something like this. So friends, after the method gets executed, we are left with only one node, which is the first and the last node both, because we are keeping the track of the last node. And when the circular singly linked list has only one element left, we know that that particular node is the last node. And if we traverse to its next, then it will refer to itself because this is the first node and the last node both. And if we call this algorithm again, in order to remove this last node from the circular singly linked list, so the demonstration of the algorithm is as follow. So first we check whether the list is empty or not. So currently circular singly linked list has one node, therefore it's not empty. So the condition in if block comes out to be false. And as we want to remove the first node of the circular singly linked list, we assign the value of last.next to temp. But here you can see we are only left with one node, therefore the last.next is pointing to that particular node only. So after this line gets executed, it would look something like this. So here you can see temp is pointing to last.next, which is the node itself. Moving ahead, and now we are checking whether last.next is equal to last or not. So as we discussed earlier, this condition will come only into picture when we are left with one node. So currently here you can see last next is pointing to the last node itself. Therefore the condition in if block comes out to be true. So the if block will be executed. So friend, in this step we are assigning null to last, because in order to remove this node, we have to break this link. If we break this link, then this node will be freed up. So when this statement will be executed, it would look something like this. That now last will point to null. And as we have broke this link, now this node can be removed easily. So after the if statement, the last step we do is we simply assign the value of null to temp.next. So currently here you see temp next is pointing to temp itself. Therefore we need to break this link. So here temp next is pointing to null. Moving ahead, and then we are simply decrementing the length by 1 because we have successfully removed the node. So now length becomes 0, and as here you can see last is now pointing to null. And in the final step we are simply returning the temp. So it would look something like this. So friends, after we remove all the elements, now if we again call this algorithm, so in the first step we will check whether the circular singly linked is empty or not. So here you can see the length is 0 and last is pointing to null. Therefore the circular singly linked list is empty. So the condition in if block comes out to be true. And as we know that when the circular singly linked list is empty, there are no nodes left to be removed. So therefore we can throw a no such element exception. because there are no nodes left to be removed. So friends, here we saw the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, we created one class by name circular singly linked list, and we implemented the code for the circular singly linked list into that particular class. So in order to understand the working of circular singly linked list, you can watch my previous tutorials. And here you can see we are keeping the track of the last node through the instance variable list node. So in this tutorial, we will write the code to remove the first node from the circular singly linked list. So here let's suppose we give the method name is public list node remove first. So friends, here I have given the method name as remove first and whose return type is of list node. So this method will remove the first node from the circular singly linked list and will return it back to us. So in the first step, as we saw in the slide, we are checking that whether circular singly linked list is empty or not. So is empty. So if the circular singly linked list is empty, we will throw no such element exception. And here we provide a string as circular singly linked list is already empty. And if the circular singly linked list is not empty, then the first step we do is we create a temp list node and we'll assign the value of last dot next to it. And then we'll provide an if else block. So in the if block, we provide a condition as that whether last dot next is equal to last or not. So if the last dot next is equal to last, then we'll simply assign null value to last, because we know that this condition comes into picture when there is only one node left into the circular singly linked list. And in that case, if we want to remove that particular node, we need to simply assign the null value to last, because this last is referring to that particular node. And in the else part, we are simply assigning temp next value to last dot next. And after if else block, we are simply assigning null value to temp next. And then we are reducing the length by 1. And in the final step, we are simply returning the temp node. So friends, this is the algorithm to remove the first node from the circular singly linked list. Now let's test its working in the main method. So friends, in my previous tutorial, we discussed how we can insert the node into the circular singly linked list. So we inserted 3 nodes in my previous tutorial with the data as 1, 8 and 10. And we also created one display method which could display the entire circular singly linked list. So if I run the code now, you can see it printed 1, 8 and 10 because there are 3 nodes in the circular singly linked list, 1, 8 and 10. Now let's say we are removing the first node from the circular singly linked list and we are calling the display method again. Now if I run the code again, so here you can see initially it printed 1, 8 and 10 because we have 3 nodes in the circular singly linked list. And when we removed the first node, so 1 got removed and it printed 8 and 10. Now let's say I again call remove first method. And if I run the code now, so you can see it removed 1 and then it removed 8 and it finally printed 10. And if I call again remove first, and if I run the code, so you can see in the second line it printed nothing because it removed all the nodes from the circular singly linked list. And when we call display, so here you can see in display method we are initially keeping a condition whether last is equal to null, and if last is equal to null, then we are simply returning from the method. So therefore it printed nothing, because when we have removed all the nodes from the circular singly linked list, we know that last point to the null. And now if I call again remove first, and if I run the code, so you can see it gave an exception as no such element exception, and it printed message as circular singly linked list is already empty. So friends, in this tutorial we discussed how to remove the first node from the circular singly linked list in Java. So friends, usually we never return the list node from a method, and we actually return the data part of the node which we want to remove. So here if we are calling remove first, so it should remove the node, but it should return us back the data part of it. So the code is similar. What we need to do is we need to change the return type to int, because the data is of integer type. And here, after pointing to the first node by going through last.next, we create an integer variable which stores the data of the first node. So we simply assign temp.data to result integer variable. So initially we were making temp.next point to null. We were doing this step because we are only returning back the list node. So now when we are returning back the data part of it, we don't require this step, because this node will be automatically garbage collected by Java. And in the last step, we are simply returning back the result. So friends, initially we removed the first node from the circular singly linked list and we returned it back. And after some modification, we are returning back the integer value. So let's test the working of this method. So here we'll just print the data which this remove first will return us back. So here we will call remove first. So here you can see there are 3 nodes, 1, 8 and 10, and then we are removing the first node. So therefore it should print the value as 1, because 1 is the first node of the circular singly linked list. And if I run the code, so here you can see initially it printed the 3 nodes with data as 1, 8 and 10, and then it removed the first node which is 1 and it printed it on the console. And when we did display again, there were 2 nodes left, which is 8 and 10. So friends, in this tutorial we discussed how to remove the first node from the circular singly linked list in Java. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.